Hello ladies and gentlemen, it's Mr. Wyatt. I'm going to go through some slant asymptote problems with you because I don't think I'm up for this with my sickness. I'm not feeling so hot. So here's what I'm going to do. I'm going to do the notes with you and then you guys can do the practice problems. So first thing here, we're going to be graphing rational functions, but they're not going to have a horizontal or horizontal asymptote. They're going to have what's called a slant asymptote. And the way you know that this is going to happen is if the degree of the numerator is more than the degree of the denominator. So just thinking of an example of that, x squared plus 1 over x, this has a slant asymptote because the degree here is 2 and the degree there is 1. When you know you don't have a horizontal asymptote, you're going to use long division and you're going to get a linear term usually. It doesn't have to be, but the problems we're working on are going to be linear, and it's called a slant asymptote. So you do long division, and your quotient is a line that you can graph. So let's try a couple here. You're still going to have to do the same things you normally do, like find x-intercepts, y-intercepts, and vertical asymptote. So to find the x-intercept, you factor the numerator. That's x minus 5, x plus 1. And that's 0 when you have x equals 5 and x equals negative 1. So I'll go ahead and draw that. 5, 0, and negative 1, 0. The y-intercept, you plug in 0. So if you plug in 0 for that, you get negative 5 over negative 3. That's 5/3. 5/3 is like 1.6 or something like that. And the vertical asymptote is when the denominator is 0. So x minus 3 equals 0 when x equals 3. That's a vertical asymptote right here. Now, there is no horizontal asymptote, and I know that because the degree here is 2 and the degree there is 1. So since the numerator has a higher degree, it's a slant asymptote. So what we're going to have to do is long division. I'm going to take x squared minus 4x minus 5, and I'm going to divide x minus 3 into it. And we've done long division a bunch, so x times x is x squared, and you distribute the x. So that's x squared minus 3x. Then you flip your signs, so now that's minus and plus. Those go away. Negative 4 plus 3 is negative 1x minus 5, and you do it again. So x times what is negative 1x? That'd be negative 1. Distribute a negative 1. Negative 1x plus 3. Flip your signs, plus minus. Those go away. And negative 5 and negative 3 make negative 8. Now that's the remainder. That actually doesn't matter in these problems. What we're really looking for is the x minus 1. That is the equation of the slant asymptote. So y equals x minus 1 is the slant asymptote in this problem. When you graph that, what you're going to need to do is graph the line y equals x minus 1. So plot some points, start at the y-intercept, negative 1, and go up 1 over 1. And these are points on the asymptote. These aren't points on the function. And when I draw that, looks like this. Now I have my slant asymptote that's going to help me. The cool thing about slant asymptote problems is there's usually only one way I can draw this thing. I know the end behavior as x goes to infinity and as x goes to negative infinity is going to follow the slant asymptotes, but I also can't cross the vertical asymptote. So I kind of have two sides that I have to work with. Here, I can't cross this vertical asymptote, so I know the function has to do something like this. And I know its end behavior approaches the slant asymptote, so it's going to look something like this. Similarly over here, it has to go up, and it can't cross the vertical asymptote, and it has to go out, and it's going to approach the horizontal asymptote. So the function is actually a little bit easier to graph, but you have to put more work in here to find the slant asymptote. Let's try another one. The tricky thing here is the denominator is not in standard form, so let me just rewrite that. That's a little annoying. This is negative x plus 1. Okay, now let's find everything. Factor the numerator, x minus 2, x plus 1, and that is x-intercepts at 2, 0, and negative 1, 0. The y-intercept is negative 2 divided by positive 1, so 0, negative 2. And the vertical asymptote, negative x plus 1 equals 0 when x equals positive 1. So let's go ahead and draw those things. Y-intercept is at 0, negative 2. X-intercepts are at 2 and negative 1. And my vertical asymptote is x equals positive 1. So like that. Now we got to find the slant asymptote, so I have to do long division. I know it's slant asymptote because this is degree 2 and that's degree 1. So x squared minus x minus 2, and then the denominator is negative x plus 1. A little weird with the negative x, but that's fine. Now what we're going to do is figure out what do you multiply negative 1x by to get x squared, and that'd be negative x. Negative times a negative is positive, x times x is x squared. Distribute that, you get x squared minus x, and then you have to flip the signs. So now this is minus plus. Those cancel out. Hey, wait a minute. Those also cancel out, and you just get negative 2. So since negative 2 is a lower degree polynomial than this linear term, I'm actually done. That's my remainder. So the line, my slant asymptote, is y equals negative x. Now, if that freaks you out, like I don't know how to graph that, that's negative 1x plus 0. So the y-intercept is 0, the slope is negative 1. So the y-intercept is 0, and the slope is negative 1. My asymptote looks like this. Let's move that down. There we go. And again, there's only one way I'm going to be able to draw this thing. You can see it's got to go up and it's got to go over. So this one goes up and it goes down along the slant asymptote. Same thing here, down, and it's not my best. Let's try this. Yeah, well, that's all I'm going to get. Okay, so it looks like that. You can graph it in Desmos to confirm, but it's not that difficult once you understand how to get the slant asymptote, which you're good at long division, so it shouldn't be a big deal. Let's do one more together. X intercepts, when you factor the numerator, you get x plus 1, x plus 1. So that would be at negative 1, 0. Ooh, that's a multiplicity. That's kind of interesting. Negative 1, 0. All right. Y-intercept, 1 divided by 2 is 1/2. It's negative 1/2. 0, negative 1/2 is right here. Vertical asymptote, x equals 2. Right here. And now we got to find the slant asymptote. Again, degree 2 higher than degree 1. X squared plus 2x plus 1, x minus 2. So x times x is x squared, distribute it, x squared minus 2x. Oh, those are going to cancel. No, they're not. Flip the signs. 2x plus 2x is 4x. Now I got to do it again. X times 4 is 4x, distribute, 4x minus 8. Flip the signs. 1 plus 8 is 9, but I don't really care about that. That's the remainder. I got what I came for here. Y equals x plus 4 is the slant asymptote. So the y-intercept is 4. The slope is again 1. So when I draw it, it looks something like this. That's pretty good, actually. It's not really a point. Okay. This one's a little trickier. I know how it's going to look down here. It's going to actually do a little turnaround action, but it's a little tougher to imagine how it's going to look up here. So what I'm going to do is graph it so it goes down like this and then over like this. And then I know that there's going to be a point over here that's either going to do this or this. I'm not sure which one it's going to be. But what I'm going to do is, let's try and make a sign chart for this thing, and let's plug in a number a little bit bigger than 2. So we'll test our end behavior at 2, we know it's undefined, and then I'll try 2.1. So if I try 2.1, 2.1 plus 1 is positive, and again it's positive, so we get a positive in the numerator, and 2.1 minus 2 is also positive. So the end behavior here is going to be positive, it's going to be up here like this. So if it's up here, it's got to go up along the vertical asymptote, and then it's going to go out like that. So I can kind of get a sense of how this thing's going to look, knowing that it's a rational function and there's going to be 2 parts to it here. So that's it for long division. There's some practice problems you should try. They're worked out on Schoology. Hopefully you guys can help each other out and get through that. And if you get through that, hopefully that's it for the day. So have a good day.